Last summer, I spoke with John Farrell about the Lake Sturgeon's comeback in the St. Lawrence River and how we would like to know what's going on beneath the surface. These living fossils, or dinosaurs of the deep, are just something magical. He replied, I know a guy. And we are excited about this guy. Matt Norvilitis is an MS candidate and researcher of the life stage ecology of Lake Sturgeon in the St. Lawrence and specializes in the conservation of imperial fish species. Let's welcome Matt.
Thank you, Bridget. I am here to talk about Lake Sturgeon in the Upper St. Lawrence and some current conservation, restoration, and ongoing research projects in the area. So zooming out, I'm assuming this is common knowledge for a lot of you, but maybe not everyone. So just taking a step back and looking at the Great Lakes, they're an incredibly large freshwater system encompassing about 20% of Earth's fresh water. All of this drains out into the Atlantic Ocean through the St. Lawrence. This is a incredibly populous region where I'm assuming most of you live. And all of these Great Lakes have Lake Sturgeon. And so do their connecting water bodies like the Detroit River, St. Clair River, and most importantly, the St. Lawrence River. And each one of these populations has a specific conservation or protection status associated with it. Zooming in on our favorite river, the St. Lawrence. The Upper St. Lawrence River is about 100 miles long and is divided up into three pretty distinct sections. The Thousand Islands behind us, the Middle Corridor, which extends from Oak Point all the way down to Waddington, and Lake St. Lawrence, which was created by the impoundment of the Moses Owners Hydro Dam. This is an incredibly diverse region with 14 species of conservation need, one of which being the Lake Sturgeon, which I'm going to talk about. I'm going to teach you why this is your favorite fish. So these are a bottom-dwelling or benthic species, feeding primarily on the bottom and living primarily on the bottom of the river. They're prehistoric. Some estimates of their family range about 200 million years old, and they're imperiled across most of their range. These fish are native to large, interconnected freshwater systems like the Great Lakes, Mississippi River, and Ohio River drainages. And because of this, they're an incredibly migratory species, capable of moving hundreds and hundreds of miles at a time. They reproduce in tributaries typically, though they can reproduce in the main stem of large rivers, like the St. Lawrence. And these fish, like I mentioned, they're benthic, so they feed on species that you find on the bottom, like mussels, insects, snails, and they'll opportunistically eat fish like round gobies and fish carcasses. These fish are sexually dimorphic, which means there's differences between males and females. Females are huge. They get up to 7 feet, and they can be up to 250 pounds. A lot of these giants are lost from the Great Lakes, but are slowly making their way back. Males don't get quite as big. They max out around 5.5 to 6 feet, and they don't live as long. They live typically 70 to 80 years, whereas those females can get up to 150 years old. Truly incredible. However, in order to live that long, you have to have some trade-offs. So they grow pretty slow, and they reproduce late in life. Males typically take between 10 and 15 years, and females typically take anywhere from 15 to 25 years to be reproductively active. And they don't spawn every year. So once they are mature, males will spawn typically every other year, and females will spawn every 2 to 4 years. This is kind of dependent on how much energy they expended throughout the year and in the previous year's spawning season. So a little bit about their history. Overfishing was incredibly devastating in the late 1800s. With some estimates of their exploitation ranging from 12 to 15 times higher than what the population could actually sustain. This is incredibly unsustainable, obviously. And so initially they were caught as nuisances, chasing around commercial fishing operations and nets, picking off dead fish on the bottom, and oftentimes getting entangled in those nets. They're seen as a trash fish, something that people had to deal with. And oftentimes there are reports of them being stacked like cordwood to be burned in the boiler rooms of steamships. However, markets developed for their meat, as people learned it actually was pretty good if you smoked it, I guess, and caviar, which is a pretty high society food, and isinglass, which was once used to make beer clear. It is synthetic now. And because of all these demands and their population not being able to sustain overfishing, the fishery crashed in about 40 years, ending around 100 years ago in the 1920s. And the fishery officially closed in New York State in 1976, ending any local commercial operations that might have persisted afterwards. Some current threats that they still are facing, the completion of the Moses Saunders Dam and the Seaway Project in 1959 severed the river in half, decreasing access to potential spawning grounds and eliminating a migratory corridor between rivers below the Moses Saunders Dam. As well, it changed river characteristics like the natural flow regime, and it homogenized a lot of the river. Additionally, the transoceanic shipping that opened up as a result of the seaway introduced many invasive species, which I'm sure you all love, like the zebra mussel and round goby. More specifically, in the upper St. Lawrence River, which is that stretch again from the Moses Saunders to eastern Lake Ontario, the Oswegatchie was the only spawning tributary outside of the main stem. And this, as well, had its share of challenges, as it was dammed multiple times. The first in the city of Ogdensburg in 1910, just a half mile from the confluence with the St. Lawrence, and again at Eelware and Hubleton in 1913, severing the river into 3 distinct sections. There is hope, though. Ongoing restoration efforts have been taken place for the last 20 to 30 years or so. I ripped this quote right out of the New York State DEC Lake Sturgeon Management Plan. The goal of all of these conservation efforts is the self-perpetuation of the species and to ultimately remove the species from the New York State threatened list eventually. So what's being done in the region? Well, some habitat improvement projects have been conducted. Two natural fish passage projects in the Oswegatchie River have been completed, which provide access to upstream spawning habitat in the Oswegatchie River around those 2 dams in Eelware and Hubleton. It's important to note the downstream dam is still impassable to fish, and Lake Sturgeon cannot travel from the St. Lawrence to the upper reaches of the Oswegatchie River. Additionally, artificial spawning reefs have been placed in the upper St. Lawrence River, and those have been used for the last 20 years by Lake Sturgeon as a way to spawn, because a lot of those fish lost access to spawning tributaries with the completion of the dam. These efforts are led by New York State DEC and U.S. Fish and Wildlife, and the biggest piece of restoration has been the Lake Sturgeon stocking program, which began in 1993. And it has supplemented multiple populations in the upper St. Lawrence River watershed, like the Oswegatchie River upstream of the dam in Ogdensburg, Black Lake, the upper river itself, and the mouth of the Oswegatchie River in Ogdensburg. In total, across New York State, about 300,000 lake sturgeon have been stocked over the last 32 years. And as one of my co-conspirators loves to say, Scott, he always tells me it takes half a career to start seeing results, and you don't know if it worked or not. And so, additional research is needed to better understand sturgeon and the impacts of some of these restoration efforts. And so that kind of brings me to my project, which I'll be telling you all about today. My research title is Juvenile Lake Sturgeon Movements, Habitat Usage, and Ecology in the Upper St. Lawrence River. And I absolutely have to shout out my co-authors, Dr. John Farrow, Scott Schluter, and David Stanley. So some little project background. Ontario Power Generation and U.S. Fish and Wildlife Service have been stocking lake sturgeon for years to mitigate some potential impacts of the Moses Saunders Dam. Like I mentioned, it severed access to potential spawning grounds, and they hope to examine the impacts of their stocking through the recapture of fish that they stocked in the past. We call these at-large fish. They are captured from the wild. So Ontario Power Generation subcontracted Kleinschmidt Associates to catch and tag juvenile lake sturgeon in the wild. In total, they caught 44 lake sturgeon, and all of those fish received acoustic tags and were released to go and collect data on their movements and whereabouts. So my project is building off of this. So the previous year's effort by Kleinschmidt have been an awesome foundation to build from, and so this project is funded by a similar source. It's funded by U.S. Fish and Wildlife Fish Enhancement Mitigation and Research Fund, which is a settlement with the creation and relicensing of the Moses Saunders Dam. And my project is looking into the movements of these previously tagged 44 fish while adding 50 more tags to the population. Of those 50 tags, 30 are going into those at-large fish, different fish that have been stocked in previous years, and 20 stocked fingerlings. So the fish that get stocked every year also got acoustic tags so that we can monitor their movements. Additionally, we hope to redefine some supporting information of the juvenile life stage in the region. Not a lot is out there about what they're eating, what they're doing, how they grow, and so we hope to add to this and redefine it with some cutting-edge technology like genetic information and stable isotope analysis. And so where does this project kind of fit into the New York State sturgeon scene? Well, we're targeting a very specific knowledge gap surrounding juvenile sturgeon. Why is this important? Well, these two quotes, which I cherry-picked from my literature search, I think sum up pretty well the plight of sturgeon. I'll read them to you. By our 1995 says, perhaps the largest gap in life history knowledge of sturgeons is defining habitat by young and growing individuals. And again, more recently by Bose, lack of knowledge about juvenile lake sturgeon habitat has hindered rehabilitation of populations throughout the Great Lakes. That doesn't define how important this project is. I don't know what will. The hardest part about most of these studies is actually finding the fish. It's pretty clear that we don't know where they are. And so that's where this study kind of comes in. So here's some target project questions that I hope to answer. This is my first year as a master's student, so I don't have all the answers yet. But these are the questions we're hoping to ask. What are their movement patterns and behaviors? What is juvenile lake sturgeon habitat? And what are their current foraging behaviors, and how does it vary across the population? These are all pretty minimally known, especially for the region, and so this project comes at a good time. Well, I keep talking about acoustic telemetry. What actually is it? Well, telemetry is the transmission of information from a living organism to a remote observer. Acoustic telemetry is the use of sound to transmit that data to the remote observer. And so GLOTOS is an international group called the Great Lakes Acoustic Telemetry Observation System that makes up the Great Lakes node of the Ocean Tracking Network. This is an international group of researchers and institutions that monitor and maintain acoustic telemetry arrays and share data across the Great Lakes Basin. And so this project is part of GLOTOS. And so talking about the array, U.S. Fish and Wildlife and some partners maintain the around 125 receivers that dot the St. Lawrence River, the Upper River, and a little bit of Lake St. Francis. This array provides massive amounts of previously difficult to obtain location information. So that animation there on the right, you can see the fish kind of going crazy. That is 44 fish over 3 years, and it's about 3.5 million data points. For reference, before this array was in place, if you wanted a location, you had to go out and get it yourself, and that was one location per day. And so this provides constant data over however long your battery life lasts. Pretty amazing, and it answers new questions every time a project like this is implemented. For example, I think of the muskie project that Tibbs is doing and how much we've learned from that, and how these previously thought to be sedentary predators are capable of making multiple 100-mile runs over back-to-back years. Pretty amazing stuff. And some other active acoustic telemetry projects include U.S. Fish and Wildlife's work with American eel and muskie, and Tibbs' work with muskie, northern pike, and chain pickerel. Oh, and U.S. Fish and Wildlife also works with walleye, and Queen's University works with smallmouth bass. And these are all projects in the region, not just projects. People put acoustic tags in just about anything. Here's a map. I understand those numbers are hard to read, and so what you need to know is down there in the bottom left by Eastern Lake Ontario are low number receivers, 1, 2, 3, 4. And up there in the upper right is high number receivers, that's Lake St. Francis. So receivers 80 to 120 are below the Moses Saunders hydro dam. And there on the left is Justin Eckert, one of the U.S. Fish and Wildlife biologists who's been a huge help with this project, holding up a receiver. And so those two orange balls are floats. Those keep the receiver upright and vertical in the water column. And in between them is the receiver itself, which records information and sits anchored to the bottom. The fact that it's anchored to the bottom means that you can only get data about once a year, so it's kind of a challenge. You can only work with your data once you get it back. So right now I'm working with all the data from the previous year. So all the fish that I've tagged are out there in the wild and on the loose, and I don't really know where they are, and I won't know where they have been until next year. How does it actually work? I've been telling you about it, but how does it actually work? So acoustic tags are surgically implanted into fish with a small incision, and then they're stitched right back up, recovered, and then they get released back into the wild. Once they get released, the tags transmit data as often as you program them to. So they can ping frequently. My tags ping every 2 minutes or 5 minutes, depending on the size of the battery. So the little tags, which go in the little guys, which in the bottom right, that's a surgery on a little fingerling. Those tags have small batteries and don't last very long. But the big guy in the upper right, he got a bigger tag with a bigger battery, and it pings more often and will last longer. These transmissions, they occur at 69 kilohertz, so I keep talking about sound. You can't hear that, I can't hear that, the fish can't hear that, and so they act pretty naturally once they're all healed up from the surgery. And so every transmission that gets sent out is a series of 7 to 9 sounds. They're called pings because they're really high pitched, I'll show you in a sec. And the space between each sound encodes for a number. So the first 5 digits are the ID, and the second 2 to 4 digits encode for whatever variables you might be interested in, like depth, pressure, or movement speed. And these can be picked up and decoded by receivers and hydrophones, which is what I use. And so when I talk about telemetry, a lot of you might have heard of VHF and GPS telemetry, but I'm telling you that that is not really how it works in deep water. So VHF and GPS are really good for terrestrial projects or really shallow water projects like in a single embayment. But across the St. Lawrence, the depth varies wildly from 70 to 150 feet, and so you need something that can travel through the water super well, like acoustic telemetry. These two, VHF and GPS, they can't be transmitted through water. And passive acoustic data describes really large-scale movements amazingly. It can tell you how far a fish has gone, when it's there, why it's there, but it doesn't give you pretty precise locations, which is what I'm more interested in. And so we do active telemetry. So we go out in a boat and we go and get those locations ourselves. And so using them together, you can provide context to your passive data while also getting more specific information with your active data. And so to do that, I call it the stop and go method. You go to a spot and then you stop and you listen for the entire time it takes a tag to make a sound. And then you go, you do it again, and again, and again, and again, until you run out of time in the day, pretty much. And that's how you get active acoustic telemetry data. So this is a video, I don't know if it'll play with sound. One second. Those are those pings I was just telling you about. That's what they sound like when they're picked up by a hydrophone. That was a second detection. So there was actually 2 fish recorded on that single hydrophone video. I'm right there in the mouth of the Oswegatchie River where it meets the St. Lawrence. Most of my sites, I have about 200 of them, yield nothing. They're kind of bland habitat, there's not many fish there. But around here, I seem to get a lot of detections with regular frequency, which is pretty awesome to see. And so I'm presenting you a very scary looking graph. I'm gonna try and break it down, and you don't need to understand it, but what is important is on the axis there. Oh, sorry. On the y-axis, you can see receiver station number. So the low numbers are closer to us and closer to Eastern Lake Ontario, and the higher numbers are down there below the Moses Saunders Dam. You can see almost all of the data falls in that red box, which is where I decided to do my sampling. Almost 85% of all the sturgeon data occurs between there, which is Oak Point to Ogdensburg. And so what does that actually look like? These are where the receivers actually are in the river. And so you can see that receiver 49 and 50, that has 70% of all of the detections. There's 150 receivers, and these two have over half of the data. So it's clear that the fish are in this area, and this is where I chose to target in my study. And so this is what I'm talking about when I say the stop and go method. So that yellow line is my track in a boat, and the center of each red circle is where I stop and drop the hydrophone. The radius of that circle is how far away I can detect the tag, and so I have to keep moving in order to make sure that no fish can get by me. So here's a video of a sturgeon's movements. That red dot, which is moving around up there near Messina, is actually a lake sturgeon that was tagged in 2022, and it got stuck below the dam. That's kind of unfortunate. That means it's not in my study area, and it's not providing a lot of good data for the upper river. But it's just kind of funny that he got stuck below the dam after going through a lock and couldn't get back upstream. Poor guy. He's stuck there. He's trying to go back upstream, but he can't. And that's kind of the problem with the damming of the river. They get stuck upstream or downstream. This fish is what I call the average fish. So it spends a lot of time there, right in Ogdensburg, which is marked. with occasional forays up and downstream. At one point it goes to Chippewa, but for the most part it spends a lot of its time in and near Ogdensburg, which is what I see out of most of the fish. Here it is, hanging out. Exactly what I expect. And as I've been told, every study has to have outliers, and so the next fish is a highly migratory fish. You can see they're not big fish, these are all juveniles. And so this guy is about to travel the entire length of the river in just a couple weeks. Give him a sec. Oh, there he goes. Moves really fast, moves a lot. Not every fish does this, only a few have showed this behavior so far. Pretty fascinating stuff. And then this is the outlier of outliers. This is not one of my fish. I picked up this fish during my summer field season. It was actually tagged in 2019 in the Genesee River by the Lower Great Lakes office. And it makes some pretty huge movements. Let's see, look at that. Traveled the entire length of eastern Lake Ontario in just a matter of weeks. Pretty amazing. Spends a lot of time there in Chameau and Black River Bay. And then it finds a home in the upper river, which is kind of where it spends most of the time in this animation. Pretty interesting stuff. This fish that was stocked hundreds of miles away chose to stay in the upper river, suggesting that there is good habitat here and that there is something desirable about staying here.
His girlfriend.
Maybe. Fish isn't mature. But yeah, for the most part, for the remainder of this animation, it spends most of its time in the upper river. Super interesting stuff. Moving ahead. So, when I was looking at the passive receiver data, I noticed some very interesting trends. And so, I isolated just the spawning season, which in the St. Lawrence is late May and early June. And so, like I mentioned earlier, juvenile fish can't reproduce. However, this fish traveled from below Chippewa Bay all the way to the artificial spawning beds, hung out for around a day, and then left. Weird. Why is it doing that? There's been only a few studies that have documented this behavior, and none of them are in the direct Great Lakes. They're all in subpopulations. One was in Lake Champlain, and one was in the Wolf River. Again, similar behavior, same time of year. Traveled from below Chippewa to the Oswegatchie River confluent, which historically was a spawning location, but that has been changed with the damming of the Ogdensburg, Oswegatchie River in Ogdensburg, and so there was spawning there at one point, but no longer. But this fish, during spawning season, was there. Very interesting. Something that you might expect to see, the fish are moving a lot in the summer and the fall, and less in spring and the winter. Their energy levels are directly tied to water temperature, and so the more they move, typically it's associated with warmer water. But why is this kind of data useful? Well, precise location from the manual tracking and from the acoustic telemetry array are great snapshots in their selection history. So you get a detection one day, that you know exactly where that fish was one day. But if you get multiple of those over a time series, you can determine where are they usually. What is important habitat? Where can they be found more often than not? And so that's what we're hoping to do. We're hoping to find and map these habitats to better understand and protect it. Juveniles are really hard to find, or at least that's what most studies have suggested to me. They have low sample sizes between 10 and 30. This study has a sample size of 94, and so it's a great opportunity to kind of outline and map that important habitat. It can influence management and influence targeted sampling, which is what we employed last fall. And so we were basing our methods off of the work done by Kleinschmidt. They had a catch per unit effort of 0.19, which means they caught 0.19 lake sturgeon per net, per night. And so that's pretty low. On average, one fish over 5 nights per one net, versus ours, we had a catch per unit effort 7 times higher. Granted, we had some differences in gear and gear application, but for the most part, I don't think that explains the whole gap in the catch per unit effort differences. And so some unofficial discussion points I'd like to reiterate. I'm in my 2nd semester. I don't even have a formal project proposal yet. And so all of this is preliminary, and I hope to have some better analysis for you next year. But so far, in the field work we've completed, finding fish was actually the easy part so far, which is not what I was expecting or anticipating. I thought I was gonna have to spend a whole month and a half in the field without going to class. And so the preliminary movement analysis is showing some interesting stuff. Using the movement data and position data is also showing interesting stuff, like that targeted sampling I was telling you about. And from what I can tell, their preference seems to be predictable. It seems to be consistent, which is not what a lot of previous juvenile movement studies have suggested, which is pretty interesting, pretty awesome, that here in the Great Lakes, in the St. Lawrence, that we can be able to find juvenile lake sturgeon when we need to. And I'm expecting to see a lot of fish this summer, because we tagged 50, hoping to find them. What is the future outlook in the upper river? Well, it's clear to me that the Oswegatchie confluence is critical habitat. Super important to the lake sturgeon. They seem to be coming back to it and spending a lot of time there. And so it's in need of protection and care. I think things are looking good right now in the upper river. According to the New York State DEC management plan, this unit is considered recovered because it meets target adult population and has evidence of natural reproduction. And as long as these fish are here, I think that's a great sign. They're very resilient. You know, they survived that overfishing. They were able to come back. Some populations have naturally recovered, like the Niagara River. And so I think that's, you know, really compelling and really helpful to understand, you know, how these guys are doing and how they'll be doing in the future. And we're working to improve their current condition with the stocking and the habitat remediation efforts. And so I think that should pave the way to a very hopeful sturgeon future. Real quick, before I go, if you see either of these two rigs out in the wild, either the boat or the boat and truck, say hi, that's me. I'll be on the river all summer and into the fall. Come say hi, I'll tell you if I found any fish, I'll tell you how I'm doing. Before I go, I have to thank a bunch of people because I can't do this alone. My co-authors and committee members, Emily Arsenal, John Farrell, Scott Schluter, and David Stanley. I obviously could not do any of this alone. And I'd also love to give a huge thanks to Justin, the Genoa National Fish Hatchery for letting us come in and tag fish, Customs and Border Patrol for allowing us to set up shop in their parking lot, Kleinschmidt for sharing some data, DEC for sharing some gear and advice, Thousand Islands Biological Station for housing me all summer, and the Farrell Lab and my unpaid workers for all of their help that they've given me, Ray, Connor, James, Cassidy, Greta, and Nick. I obviously could not have done any of this without them as well. Some fun numbers in the bottom right if you're interested. And here's some references I threw in there. Happy to talk about them with you, and I can field any questions.
Are there any discussions or plans about creating a passage around the lowest dam in the Oswegatchie?
I think it's been floated before, but as of right now, not to my knowledge.